Okay, this is the second part of doing 10 random easy Leetcode problems. We have done 5 before, doing another 5. This is problem number 6. Let's look at the problem. Find reading and repeated values. Find missing and repeated values. We are given a 0 index to the integer grid of size n cross n with the values in range 1 to n square. Each integer appears exactly once except a, which appears twice, and b, which is missing. The task is to find the repeating and the missing numbers a and b. Written a 0 index integer array, answer of size 2, where answer 0 equals a and answer 1 equals to b. All this is fine. 1 3 2 2. 2 is repeating and 4 is missing. How do you do that? One option obviously is to do the sum, right? You do the sum and then what? You use sum of the array, and then whatever is the difference is okay, let's see if XOR works. So you have 1 2 3 4, but you do 1 2 2 3. Okay, so if I do XOR 1 1 2 2, I mean the repeated number, there is another way to find the repeated number, which is you just check which number is repeated. That is easy to find. I think both are easy. Just place them where they belong. Right? Just place them where they belong. Some interposition or something like that. To this is, for example, this 1 you place 1 where it belongs, 2 you place where it belongs, 2 place it at position number 2. So it's a 2D array, I comma j. I think I'm getting it. How do I transpose is the question. Well, presence, make it minus. Where? Okay, presence, make it minus. So let's do this. For int I equals to 0 is less than grid dot length I plus plus int j equals to 0, j is less than grid 0 length j plus plus. The value here present is I comma j. Now this value, we know it's in the range 1 to n square. So 1 3 4 5 6 7 8 9, like that, right? So it's if I make it 1 based index, then row equals to I think you have to find that n thing, right? Let's find n, not n, I mean whatever the size, yeah, just call that n. So for example, let's say you get 1 2 3 4 5, right? So 5 row number is 1 and column number is 1 2 3 2. So it's 5 and then 5 percentile and 5 percentile 3 is 2. Yeah, so 1 minus 1 and for example 4 would be 1. 6, for example, 6 divided by 3 is 2, so your row number is 2. Wow, that's not working. Okay, 1 2 3 4 5 6 7 8 9. 6 is goodness gracious me. Okay, 1 2 3, all of them should get the same row number, but they are not. So you do value minus 1, it becomes 0 minus yeah, value minus 1. So now 1 2 and 3 will become 0 1 and 2. Divide all of them by 3, you get 0. So that's fine. So that's your row number. Column number 4 5 and 6. Okay, let's apply it on 4 5 and 6. 4 5 and 6 will become 3 4 and 5. Divided by 3, it comes as 1. 7 8 and 9, subtract by 1, it becomes 6 7 and 8. Divided by 3, all of them gets 0. So it's working. Row number 0. The column number percentile 3. Okay, so 1 2 and 3, let's do 4 5 and 6. 4 percentile 3 is 1. 5 percentile 3 is, again 4 5 and 6, you make it value minus 1 first of all. So 4 5 and 6 becomes 3 4 and 5. Percentile 3 is 0. Percentile 3 is 1. Percentile 3 is 2. Yeah, this is again working. So you do this. So now what you're saying is if the value is present, then you make its indication as negative. So you do okay. So what this will do is it will tell you which or all the positions that are present. Now there will be two things that will be left. One which is double, and for that it's easy. Okay, so if this is less than 0, that means it is already present. So okay, A appears twice, B is missing, so A appears twice, right? So this is the one that appears twice. Okay, it appears twice. And whichever is positive, another loop. Okay, now this is the result of 1. You have to create the value out of it. How do you create the value now? 0 0 is 1. So you do okay, let's see what happens. 0 0 0. Does this work? I into n plus j plus 1. So 0 1 2 3. This is, let's take the middle one. So let's take 1 1. 1 1 is 1 times 3, 3 plus 1 4, and then you do plus 1. Yeah, I guess it is working. So you do this, and now you do return result. Okay, let's check. Plus plus. Run it. Submit it. And it works. Let's move to problem number 7. Okay, replace all question marks to avoid consecutive repeating characters. Given a string as containing only lowercase English letters and the question mark character, convert all the question mark characters into a lowercase letters such that the final string does not contain any consecutive repeating characters. You cannot modify the non-question mark characters. It is guaranteed that there are no consecutive repeating characters in the given string except for question mark. Return the final string after the conversions, possibly 0, have been made. If there is more than one solution, return any of them. It can be shown that an answer is always possible with the given constraints. Question mark ZS. There are 25 solutions for this problem from AZS to YZS. All are valid. Only Z is an invalid modification, as the string will consist of consecutive repeating characters in ZZS. I mean, so when you're converting it into something, don't you think it's just that okay, you have to give one solution, is that's it? Hmm. Looks quite simple to me, to be honest. I first need to convert this into a array, and whether or not is these arrays modifiable, that I don't know, but okay, char. Now is this immutable or not, this array? I don't know, but let's see. If it is a question mark, you need to convert it, and you cannot convert it into a character which is same as what's there before and what's there after. I mean, you know. If I is equals to 0, or C is not equals to array of I minus 1, and I is equals to array dot length minus 1, or C is not equals to array of I, then you will replace it. So array of I, not array of I, array of I plus 1. This is problem number 8, right? Oh, this is problem number 7. Okay. Then array of I equals to C. So you've done that. Okay, let's run. Okay, submit. It's 26 times n is the answer, and it works. Okay, let's move to, this was problem number 7. Let's move to problem number 8. Problem number 8. Divide an array into equal pairs. You are given an integer array nums consisting of 2 times n integers. You need to divide the nums into n pairs such that each element belongs to exactly one pair and the elements present in a pair are equal. Return true, the nums can be divided into n pairs, otherwise return false. 3, 2, 3, 2, 2, 2, 2. There are 6 elements in nums, so they should be divided into 6 by 2, 3 pairs. If num is divided into 6 pairs, 2, 2, 3, 3 and 2, 2, it will satisfy all the conditions. 1, 2, 3, 4. There is no way to divide into 2 pairs such that all pairs satisfy every condition. Each element belongs to exactly one pair. And doesn't matter, the element present in a pair are equal. So what you need is the count of each element has to be e1. If the count of any element is not e1, then it's a problem. And that's it. Nothing else, nothing more. Count of each element has to be e1. So you make a hash map or something. What is the size of n and how long it can be? So n is 500. Make a array of size 500. 500. It's 0 for each num in nums array of, okay, let's do 501 to make it easy. Plus if it's odd, it's not possible. Otherwise it's possible. This is your problem number 8. Run. Submit. Alright, let's do problem number 9. Check valid. Check if every row and column contains all numbers. An n-cross-n matrix is valid if every row and every column contains all integers from 1 to n. Given an n-cross-n integer matrix, return true, the matrix is valid, otherwise it is false. 1 to 3, 1 to 3, 1 to 3. That's a boring boring problem. Okay, so how do you see every is it column as well? Every row and every column contains all integers, so you will go through each row and then you will go through each column. And so that what that means is you're going through every element twice, because it will come in a column, it will come in a row, which is fine. So 2 times n square is your time complexity. And but what do you do when you're doing that analysis? Well, while doing that analysis, what you do is for every row you check if it contains all the elements, and the way to check would be same thing. If the count of anything becomes twice, or can it contain any value, like what is it, what is a range, and it can contain 0 to 100, matrix of I is, so the value will always be less than or equal to n. That means somebody will be repeating. Okay, somebody will be repeating. You can choose to use a space, or you can also do it without space, I guess. Okay, let's do this. I think for it to happen, just the count of everything has to be 3, has to be n. Okay, 1 1 1 2 2 2 3 3 3. It's not done. Okay, it's like is it a Sudoku sort of? I think you don't even need this. Let's make it even simpler, slightly simpler. I think using like a O of n space is not that. I mean, I want to avoid using O of n space. You can do 2 iterations and remove the minus and things like that. So I mean, like negative marking, negative sign you can use. So let's try that. And just do it again, I guess. Remove any negative marks. If you are here, that means it's a valid row, and if it's a valid row, that means everything has been marked negative. And if everything has been marked negative, you just do negative or negative. And you return true, and you do same for column valid. So our time complexity is of n square if n is this, and space complexity is of 1. Okay, is row valid, is column valid, matrix of column, इसको रो कर देते हैं. If well minus 1 of column system is hung, and sorry about that. R equals to 0 less than n r plus plus matrix of r column is to of. Okay, so this is our 9th problem. We are doing it in linear time and constant space. Hopefully this works. Our space complexity should definitely be better. Oh, it's a wrong answer somewhere. Most of the test cases passed though. We have returned true but expected was false. 1 2 3 1 2 3 3 1. Interesting. Let's make this up. What happened here? Why did we fail? So 1 2 3 2 1 2 and 3 3 1. So n is 3. 1 3 would have passed, then we would have come to 2 1 2. 2 we would have made something negative. So when we're going to 2, it should have failed at 2 itself. So 2 means this should have been made negative, and then 1 means this should have been made negative, right, like this. And then when I come to this 2, it would have again tried to make this is negative, but this is already negative, which is a problem. So it should have returned false. Okay, so is row valid? Okay, value is match dot absolute. It's correct only, no? What's the problem? Okay, let's use this test case. Should have returned false only, yeah. I think this is sufficient. Let's run. Case number 3 will print. So case number 3, you look at row number 0, 1 2 3, row 0, 1 2 3, row 0, 1 2 3. What the heck, bro? Somewhere you are keep doing the things for row 0 again and again and again. Ah, see, stupid shit. Okay, let's remove the prints. Even with this, most of the test cases passed. Uh, uh, uh. System is so slow, I can't say what to do. Okay, submit. This is what, problem number 9? Apparently. Alrighty, last problem of the day. So quite big, rank transform of an array. Problem number 10. Given an array of integers array, replace each element with its rank. The rank represents how large the element is. The rank is the following rules. Rank is an integer starting from 1. The larger the element, the larger the rank. If two elements are equal, their ranks must be the same. The rank should be as small as possible. 40, 10, 20, 30. Rank is 4, 1, 2, 3. I think I get it. 100, 100, 100. Rank is 1. I think I get it. I do get it. How do you solve it now? Sorting the array. You lose the relative positioning. Sorting the array with indexes. Something. Getting somewhere. So you take the original array, create a new array, and then sort it. Or let's say copy of an array and sort it. I think index is easier, definitely. So let's consider this 40 and 20, 30. Yeah. Now you're gonna sort it, means you'll get 10, 20, 30, 40, and 10 was with 2, 20 was with 3, 30 was with 4, and 40 was with, I think it's saying the largest is the largest rank. Yeah, okay, 40 is with 1. Now ten has rank 1. Okay, so when I say 10 has rank 1, that means that index 2 put rank is 1, and then 20 is different than 10, so rank increases by 2. At index 3 put rank as 2, at index 4 put rank as 3, at index 1 put rank as 1. Oh, sorry, rank at 4. I think you got it right. Yeah, I got it. Okay, if you get it, then you get it. So take an extra space,